So let's get into multiplying polynomials. So remember that if you have an expression like x to the n, this is a power. That exponent of n is a power saying we're going to take x times itself that many times. So in 3 to the 4th, this 3 is our base, and this 4 is our exponent. And so that's taking 3 times itself 4 times. Okay? So what if we wanted to take the product of powers? Like we had 2 squared times 2 to the 5th. Well, 2 squared is 2 times 2. And 2 to the 5th is 2 times 2 times 2 times 2 times 2. All right, so if I wanted to simplify that, that would give me 2 to the 1, 2, 3, 4, 5, 6, 7. 2 to the 7th. I'm taking 2 times itself 7 times. Okay, what if we had x to the 3rd times x? Well, x to the 3rd is just x times x times x. And x to the 1st here is just plain old x. So that's going to give me x to the 1, 2, 3, 4. X to the 4th. So what's the pattern here? What's going on when we're multiplying these same bases together? Because notice the 2's are the same base. The x's are the same base. So when I'm multiplying them together, notice that you are adding the exponents. 2 plus 5 is 7. 3 plus 1 is 4. So we add the exponents when we're multiplying the same base together. All right, just think. The best way to think about this is think how many 2's am I multiplying? If I'm doing 2 squared times 2 to the 5th, in total I'm multiplying 2 by itself 7 times. X to the 3rd times x, in total I'm taking x to the 4th because I'm multiplying x by itself 4 times. All right, so why are we talking about these exponents? Because now we're going to get into multiplying exponents. All right, so how would I take 2x times 6x squared minus 3x? Well, I'm going to distribute just like I would if it was just a plain old number. But now, in just multiplying the numbers, instead of just multiplying the numbers, I have to multiply the x's. So 2x, so I'm going to take 2x times 6x squared minus 3x times 2x. That's kind of the distribution there. So 2 times 6 is 12. X times x squared is x to the 3rd, because I'm taking x times x squared. So in total, I'm taking x times x times x, which is x to the 3rd. And then I'm taking minus 2 times 3, which is 6, and x times x, which is x squared. All right? And then I cannot combine these because these are not like terms. One has an x to the 3rd, one has an x squared. So there's nothing else that I can do there. What about here? If I'm multiplying or if I'm distributing this negative 3a squared into everything, so we take negative 3 times 7, which is negative 21, a to the 2nd times a to the 2nd, which is going to become a to the 4th. Then we distribute, so I guess that we did that one. Now let's do negative 3a squared times negative a. Well, negative 3 times negative 1 is positive 3. And then a to the 2nd times a is a to the 3rd. And then lastly, we've got to distribute this negative 3a squared to the 4. So negative 3 times 4 is negative 12. And then this a squared is just coming along for the ride. So there we get that. Okay? Let's do C. So if I distribute this 2p, so 2p times negative 4p squared, that's going to give me negative 8p to the 3rd. And then 2p times 5p, that's going to give me 10p squared. We also got to distribute this negative 5. So negative 5 times 2p squared, that's negative 10p squared. And then negative 5 times 20, that's going to give me negative 100. All right, but now notice I do have like terms here. I've got a p squared and a p squared. So 10p squared minus 10p squared, this is going to cancel out and leave me with negative 8p to the third minus 100. All right, and then our last one, distribute the 3. So that's going to give me 15b squared plus 6b minus 12. And then I also need to distribute this negative b. So it's going to give me minus 7b to the third minus 2b squared plus 3b. So now I need to see if I can combine like terms. So I got a b squared here and a b squared there. So 15b squared minus 2b squared, that's 13b squared. Then we got 6b plus 3b, so that's going to give me plus 9b. And then I've got a negative 12, that's kind of by itself. And I've got a negative 7b to the third, which is by itself. All right, now, the only thing I need to fix here is write it in standard form of a polynomial, which means I need to move this to the front. So negative 7b to the third plus 13b squared plus 9b minus 12. All right, and that's how we multiply a polynomial by a monomial. Notice what we were distributing there was just a monomial. 2x is just one term. Negative 3a squared, just one term. 2p, just one term, okay? So we were distributing a monomial inside the polynomial. All right, but what if we wanted to multiply two binomials together? All right, so we got x minus 3 times x minus 5. Well, how does this work? Well, we need to multiply everything inside x minus 5 by everything inside the x minus 3. So I might be saying, how does that work? So we are going to use, we're going to double distribute. Double distribute. Okay, so what does that mean? What does that mean? That means I need to take everything from x minus 3 and multiply it by everything inside x minus 5. So I need to take the x times x minus 5, and I need to take the negative 3 times x minus 5. Okay, so that's kind of how it looks written out. And then from there, we just distribute. So we get x squared minus 5x minus 3x plus 15. But notice we've got these like terms here. So we got x squared minus 8x plus 15. So we are double distributing. We're taking everything from the first and multiplying it by the entire second binomial. All right, so like in this next one, we're taking y times everything in the second binomial. So y times 3y plus 4. And this negative 2 times everything here. So negative 2 times 3y plus 4. All right, and then after we got that, then we can distribute like normal. So we get 3y squared plus 4y. Distribute this negative 2. We get negative 6y minus 8. Combine my like terms, we'll get 3y squared minus 2y minus 8. Okay, so make sure if you are multiplying multiple terms together, like these binomial times a binomial, you got to make sure you are distributing everything correctly. Okay, because we're multiplying all of x minus 5 by all of x minus 3. We're multiplying all of 3y plus 4 by all of y minus 2. All right, moving on. So kind of a word problem here. The area of the rectangle is base times height, or length times width. write an expression for the area and perimeter of the rectangle. Okay, so it says area first. So let's do area. That's base times height. So this is my base, this is my height. So we need to take 4x plus 1 inside parentheses and multiply that by all of 3x plus 2. All right, so I'm multiplying two binomials together, which means I need to double distribute. So 4x times 3x is 12x squared. 4x times 2 is 8x. And then we got 1 times 3x, which is 3x. And 1 times 2, which is 2. Combine like terms if you got them. So we get 12x squared plus 11x plus 2. So this expression represents the area of that rectangle. All right, so we multiply those two things together. How do I find perimeter? So to find the perimeter, what we need to do is we need to add up all the sides. So remember, a rectangle, the opposite sides are the same. So we could fill in the rest of this. And so for perimeter, all I got to do is add up all the sides. But notice how the lengths are the same and the widths are the same. So I'm going to take 2 times 3x plus 2 and add 2 times 4x plus 1. If I distribute here, I get 6x plus 4. If I distribute here, I get 8x plus 2. Then if I combine like terms, the perimeter is going to be 14x plus 6. So this represents perimeter. Okay? So we are getting there. We're getting there slowly but surely. Unfortunately, the bell is going to ring soon, so I'm going to have to make this a 2-part video. So make sure to tune into the next part where we go over the final examples. All right, but make sure you're practicing that double distributing idea.